Welcome to Classifying Chemical Reactions number 3. Please pause the video and read these instructions. I'll also point out that I will actually be doing the part that is X'd out. I took that out on lab days because of time, but we're all on the same pace here, so I will be doing that part as well. Okay, this reaction is one that we cannot replicate the observations, unfortunately, and I'll explain why in a second. But I'm going to go ahead and go through the process and do what we can do with it. The chemical we have on this one is something called ammonium carbonate. Make sure that you have that chemical name written down in your word equation. Go ahead and write that down in your word equation if you want to. You will, just as a heads up, need to use our good old pink sheets on this one because ammonium and carbonate are both polyatomic ions. I don't actually expect you to know what those are, just as a reminder. All right, so what we are going to have is I'm going to have a test tube with just a little bit of ammonium carbonate scooped into it. About yay much. And then we will heat this over a Bunsen burner flame. So I will now light my Bunsen burner. Okay, it says on our handout here, let me read this to you. We're testing specifically for an odor on this one, and that obviously we can't do via internet. But I will explain what it's similar to in just a second. So what we do on this one is we heat this over our Bunsen burner flame for approximately 10 to 15 seconds. And then after 10 to 15 seconds, I'm going to waft the fumes towards my nose. Remember, wafting, we want to pull the fumes towards us. We do not want to stick our nose directly over this test tube. So, we go like this. And if I don't smell it yet, I'm going to continue to heat for another 10 seconds. And I will, one thing I tell every group that ever does this one is you won't have to wonder if you smell it, you will know it. So if I waft again, there I definitely smelled it. And so well, yeah, there's no mistaking it. Again, that, you can see if you can smell it through the computer. If you can, please let me know, because that's some sort of cool powers I'm not aware of. Another observation while I have this out here that you can possibly see. Go ahead and shut my Bunsen burner off. I don't know if you can actually see this or not. But if you look closely up near the top, there's a little bit of condensation up there, which is important. Another thing that I will do, these are pH strips, and if I hold it over, see that tip of it there? See that there's a little bit of blue? That blue on the pH strip is something that those of you that go on and take college chemistry, or even more so probably in biology than chemistry, you study pHs. But pH, neutral pH is 7, and that's the orangish color that the strips are. Low pHs are acidic, and that's the red ones. pH of 1, you might be able to see there, is red. High pHs are basic, and that you can see there pH of 12 is that blue that we saw a little bit of on our pH strip. And why that's important is this does indicate that one of our products is a base. Now, the smell. The two things that if you have in your home, you can go take a whiff of these and to see what they do smell like. But what the actual smell is ammonia, household ammonia. And some of you might have that as a cleaning product in your home anyways. If you don't actually have pure ammonia, or sudsy ammonia as it might be called, ammonia is one of the primary cleaning ingredients in Windex or window cleaner. So those are two places that you might be able to go smell it. Again, there's a very distinctive smell to it. It's also a base, which is again why it created this is blue. Now, I want to start talking about the part B for this a little bit. Something I will tell you right now is predicting the products for this one. This is the most challenging of all of the reactions that we do, and I would not actually expect you to be able to do that yourself. So just as a heads up, don't panic if you're not sure how to predict the products for this one. We will look at that together when we get to part B, and that concludes part A for reaction number 3.